Now we're going to learn how to find the dot product of two vectors. So if we have two vectors and you're asked to find the dot product, all it means is multiply the x's or the a's, multiply the y's or the b's, and then add them together. Let's look at this first example. It's already worked for us. We want to find the dot product of 512 and negative 3, 4. So we're multiplying this vector times this vector. Okay? We multiply the a's, 5 times negative 3, multiply the b's, 12 times 4, and then add them together. 5 times negative 3 is negative 15, 12 times 4 is 48, negative 15 plus 48 is 33. So the dot product of these two vectors is 33. So how about this example? Find the dot product of V1 and V2, then find the angle between the two vectors. Well, V1 times V2 is going to be equal to 5, 2 times 3, 7. Right? That's where these came from. 5, 2, and 3, 7. So we multiply the a's. I don't need that. And we add it to what we get when we multiply the b's. So we get 15 plus 14, which is 29. This is our dot product. Now to find the angle between them, we have to use the formula cosine theta is equal to v over the magnitude of v times u over the magnitude of u. That was up here, I just didn't talk about it yet. That's our formula for finding the angle between them. Okay, this is our formula. So the first thing we have to do is actually find the magnitude of each one of those. So let's move down here. The magnitude of v is equal to the square root of a squared plus b squared. So we have 5 squared plus 2 squared. So we have the square root of 25 plus 4, which is the square root of 29. And then we need to find the magnitude of u. That's going to be 3 squared and 7 squared. So we end up with 9 plus 49, which is the square root of 58. Okay. So whenever we find u over, let's do v over the magnitude of v, we end up with 5, 2 over square root of 29. So we have 5 over the square root of 29 and 2 over the square root of 29. And then u over the magnitude of u is going to be 3, 7 over the square root of 58. So 3 over the square root of 58, 7 over the square root of 58. So now cosine is equal to this vector times this vector. See if I can grab another piece of paper real quick. Sorry about that. There we go. So we have 5 over the square root of 29, 2 over the square root of 29, times the dot product, 3 over the square root of 58, 7 over the square root of 58. That's what cosine theta is equal to, based on this formula right here. Okay, so then how do we calculate this? So remember, you multiply the a's and add it with what you get when you multiply the b's. So we have 5 over the square root of 29 times 3 over the square root of 58 plus 2 over the square root of 29 times 7 over the square root of 58. 5 times 3 is 15. 29 times 58 is actually 1,682, I believe. 2 times 7 is 14. That's still the same denominator. So we end up with 29 over the square root of 1682. We can approximate that. 29 divided by the square root of 1,682 is about 0.707106 . What I'm going to do is store that. So I stored it in x. Now remember, cosine theta is equal to that. We have cosine theta. I didn't know you couldn't see all that, sorry. Cosine theta is equal to approximately 0.707106, all this stuff that I stored in x. Okay, I stored that already. So I need to take the inverse cosine of theta of this number to find out what my theta is. So this is how I'm going to do that. Second cosine, second answer. So that just means take the inverse cosine of that number. And I get 45 degrees. So in this problem, it asked us to find the dot product, which we did here. That was this number, the dot product, and then find the angle between the two vectors, which we found to be 45 degrees. That was fun, right?